right, so we're asked a very simple question, which is, are x and y both positive? So are x and y both greater than 0? Yes or no? It's a yes-no data sufficiency question. Now, evaluating these two statements independently is our first step. So looking at statement 1, I think it's very important to be able to conceptualize this as a simplified version of the formula. They're not going to give you the best version of the formula most of the time. So it's going to be up to you to rework it into something a little bit more usable. So in statement 1, I've converted this formula by adding 2y to both sides and then by dividing both sides by 2 to get x is equal to y plus 1/2, which means no matter what I put in for y, x is going to be 1/2 larger. And on a number line, what that looks like is x is to the right of y, and the distance between them is 0.5, no matter what. So even if y were a negative number, x could still be a positive number. They could both be negative, or they could both be positive. So clearly this is insufficient in terms of telling me if they are both positive or not. It's possible, but it doesn't have to be true. Statement 2 says x over y is greater than 1. And this is a situation where you don't want to make some sort of sloppy reorganization because you don't know if y is positive or negative. So if you're going to multiply y on both sides to get x is greater than y, you're assuming that you've multiplied a positive number, because if you multiplied a negative number, you would end up with a formula that looks like this, because you have to flip the sign when you multiply or divide across an inequality by a negative. So what I would say is, first of all, if you're good with interpreting this information, which is if y is positive, x is greater than y, which obviously means x would also be positive because there's no negative number that's greater than a positive number. And if y is negative, then x is less than y, meaning x is more negative. If you're able to interpret that, great. Most people can, but most people will also struggle with understanding what they've just done when they get into this situation. And under time pressure, it can get confusing. So what I would say is, can you find situations in which both of these numbers are positive and other situations in which they're not? So I definitely can find a situation where they're both positive, like 5 over 4 is greater than 1. And I can also find a situation where they're not, like -5 over -4, which is also greater than 1. So once I've found that, I've proven it is insufficient because they could both be positive, but they don't have to be. And now what we want to do is take the two statements together. The two statements together say x is greater than y by 1/2. And basically, I know that the absolute value of x is larger than the absolute value of y, and they both have the same sign. So I know the top of the fraction has a larger absolute value than the bottom of the fraction, and I know that they're either both positive or they're both negative because they give me a positive sign out and they give me a number where the top of the fraction is bigger than the bottom. So as I look at this, I see that in order for x to be 1/2 greater than y, I'm either going to have a situation where like y is 4 and x is 4.5, or where x is 4 and y, or -4 and y is -4.5. And what we notice is in this negative situation, the y actually has the larger absolute value. So if we were to plug these in for x and y in the formulas that we had over here, we would find that x, which is -4 over -4.5, is not greater than 1. And so we're not able to use this as a set of possible integers for x and y because it doesn't follow both of our rules. And in fact, the only numbers that follow both of our rules are numbers where the absolute value of x is greater than the absolute value of y, and they both share the same sign. And since x has to be greater than y by 1/2, we know that in order for x to have a bigger absolute value, they're both going to have to be positive, like the 4.5 over 4 scenario, which is greater than 1. So this is a pretty tough thing to see logically, but it is sufficient when taken together. And the reasoning is based on absolute value as well as number line, understanding if it's to the left or the right, and also probably being able to understand how you should treat these inequality symbols when you are multiplying across a variable that you do not know the sign of. And so you have to be careful there. You will get two possible scenarios, and then you're going to have to deconstruct that. It's one of the more challenging questions on a test. I like plugging numbers because if you can't find any numbers that follow both rules that are not both positive, then that means they must always be both positive in order to follow the rules. And that will prove that essentially the answer to this question is always yes. And our answer to this question is answer choice C. The two statements together are sufficient.